Welcome students, welcome to my channel. In today's video, we will see that how to solve a problem using the inclusion-exclusion principle of set theory. So in this problem, it is said that among 100 students, 60 took algebra, 50 took biology, 40 took chemistry, 30 took algebra and chemistry, 25 took algebra and biology, 20 took biology and chemistry, and 15 took all the three subjects. Then how many took at least one subject? So the first thing to solve this kind of problem is to draw the Venn diagram so that we can easily understand our required region. So here I'm drawing the Venn diagram. This is a universal set. This is the set A, which represents algebra. This is set B, which represents biology. And this is set C, which represents chemistry. Now, according to the problem, the total student, that is cardinality of T, that means the total student is 100. Algebra is taken by 60 students. Biology is taken by 50 students. Chemistry is taken by 40 students. 30 took algebra and chemistry. Now, when we are talking about and in set theory, it implies intersection of two sets. So, A intersection C, this modulus here represents the cardinality, that means the number of elements inside a set. I hope all of you know that. So A intersection C is 30. Similarly, A intersection B is 25 and B intersection C is 20, while 15 took all the three subjects. That means A intersection B intersection C, that is equals to 15. Now, our required region is how many took at least one subject. That means the total number of students who took either one of the subjects or any two combinations of the subject or any three combination of the subjects. That means we have to find total number of students that who has taken any of the subjects or any two of the subjects or all the three subjects. That means you have to find the union of the three sets, A union B union C. You can use the word at least as a keyword of union of sets. So here we have to find this region. Now, what is the formula? According to the inclusion-exclusion principle, the union of three sets is represented by the formula set A plus set B plus set C minus set A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. We are subtracting this intersection of two combinations of sets because here we have already included the three sets A, B, C. So when we are including A, B, C together, that means this common portion between two sets are already included there. So if we add this intersection again, that means we are considering this intersecting portion twice inside each of the unions. And lastly, we are adding this intersection of the three sets. Why? Because we have already subtracted this common portion from A plus B plus C. But we are adding A intersection B intersection C here because as we subtract all the three common region from A plus B plus C, so this small portion which includes the intersection of the three sets was already subtracted. So that is why we are adding A intersection B intersection C. Now just put the values here. So it is 60 plus 50 plus 40 minus 30 minus 25 minus 20 plus 15. By calculating this, we will get here, it will be 150 minus 30 plus 25 plus 20, that means 75 plus 15, which gives us the value 90. So, how many took at least one subject? The answer is 90. 90 students took at least one subject. So, this is the solution. I hope it is clear now that how to draw the Venn diagram and how to identify the required region and how to apply the formula as per the inclusion-exclusion principle of set theory. So this is all for today. If you like this video, please do like, comment and subscribe my channel. Thank you. See you in the next one.